Hello, and thank you for joining us today for our second installment of our new webinar series, In the Lab with Origin and Cause. Today, we'll be discussing water component failures. My name is George Costandi. I'm the Business Development and Marketing Manager at Origin and Cause, and I'll be the moderator today. We're really excited about today's webinar. We have people joining us from every single province in Canada. We also have people from all over North America, even down south from Kansas. So welcome to everyone. I just wanted to go through a couple of quick points with you first. By now, you should have clicked on the link so that you've signed in and your attendance is accounted for so that you can receive a completion certificate after the webinar takes place. We'll be doing a live Q&A at the end of the webinar, so please feel free to submit questions via the text box under the webinar screen there. We'll try to get to as many questions as possible within the hour. If we don't get to your question in the webinar, we promise to follow up with you after the fact to make sure your questions are answered. We also will be recording a podcast answering all the questions that were submitted, and that's something that you could listen to as well. It'll be available to you on our website. We'll be sending you guys links then. All questions will be anonymously addressed unless you want a shout out. So just write your name and the company that you work for if you wish, then your question and comment. The webinar is being recorded and will be posted on our website, on LinkedIn and YouTube pages, so please feel free to pass them on to your colleagues or even use them in your team meetings if you wish. We'll be sending each of you a completion certificate in a follow-up email. For those who are not signed into the webinar under their name, but are attending within a group, please email me at webinar@origin-and-cause.com, and I'll have one made up for you. Again, that's webinar@origin-and-cause.com. At the end of the webinar, when you close the window, the program will prompt you to answer 6 quick questions about the webinar. We'd love to get some feedback from you. Things about ranking our speaker, ranking the content, asking you about future topics that you wish to learn about. These are all incredibly important to us because we want to make sure that whatever we are presenting to you is relevant and something that you can immediately incorporate into your work. And if you're experiencing any technical difficulties throughout the webinar, you can email our team questions to webinar@origin-and-cause.com. And of course, join in on the conversation on Twitter via #OCWebinar. Okay, let's get started. I'd like to introduce our speaker. Today, Eduardo Mari will be joining us. He has a master's degree in material science and engineering. He has over 15 years of experience and has led over 500 forensic investigations. He's a member of the National Association of Corrosion Engineers and as well the Professional Engineers of Ontario. And without further ado, I'll pass on the mic to Eduardo.
Thanks, George, and thanks to everyone for joining us today. I'm excited to speak with you about plumbing component failures and show you a few things that we commonly do in behind the scenes before we provide you with our report. I'd like to quickly go through the presentation main topics with you, and then we'll jump right into it. First off, we will be starting with a couple of water loss demonstrations so that you can see how water losses commonly happen and progress. The demonstrations will be on a braided hose as well as on a water filtration system. Then I'd like to discuss with you what we usually do on scene as well as in the laboratory when conducting a forensic investigation. This will bring us up to the point when we send our clients a report so that they can proceed to confirm, deny a claim, or confirm liability details, or even subrogation strategies going forward. And this will bring us to the conclusion of our presentation, a topic that I think is of great importance to discuss, which I call Subrotalk. This will link all the information we've learned about how water losses take place and the investigative process, and how it all works together to assist you in potentially recovering the cost of your claim. And I have a couple of really important tips I'd like to share with you in our Subrotalk, so make sure you're listening. Then, we have a few minutes for Q&A, and I'll be happy to answer any of your questions or thoughts. Okay, so let's jump right into it. So the first demonstration I'd like to do today is on the braided hose. As you can see, This is a typical setup other than the fact that the toilet is pink, but everything else is exactly as it would be in a regular bathroom. All the plumbing connections and everything. This braided hose does not show any particular damage. Basically, it looks fine. There's no indication of any damage or degradation whatsoever. The failures of these braided hoses are very unexpected, and the amount of damage that they can cause is tremendous. Typical losses can reach over $100,000. So without further ado, let's see what happens when we turn on the water. Look at how much water is coming out of this hose. It's actually quite a lot. Let's go and measure how much it is. So I want to measure how much water is actually coming out of this hose, because it's a tremendous amount. Let's see how much time it takes for it to fill this 5-liter jug. So this is an awful lot of water. It's actually between 20 and 40 liters per minute. What that means is in an 8-hour period, say your insured goes to work and comes back home, their house can be filled with 20,000 liters of water. That's enough to fill a typical size basement all the way to your knees. The next demonstration I'd like to do is on a water filtration system. So here we have the water filter set up. Let's see what happens. That's a lot of water, eh? That filter must be cracked or damaged somehow. Actually, that's as much water as it was coming out from the braided hose we showed before, roughly about 20,000 liters. So at this point, we want to take that filter back to the laboratory and examine it in more detail. Our process begins when we receive your claim via email or a phone call. We review the loss description and discuss the details with the client. After that, we contact the property owner or the site contact to schedule a site visit. Once on site, we conduct our visual inspection, we document and photograph the scene, we review any supporting documentation, we discuss the loss with any witnesses, and we transport the evidence back to our laboratory for further examination. But before you notify us of your new claim, we strongly suggest you do the following. When the claim comes in, advise first responders to take photos, videos of what's happening. This is very important. Decide if a forensic expert is needed for your claim, and try to contact the forensic expert before any work is conducted on site and arrange for an in-situ examination. You'd be surprised how fast we can get on site. Sometimes I can get out there within a few hours. Preserve the site and the evidence in the as-is condition. Do not allow removal and or repair or alteration of the evidence. Take photographs of the site, the evidence, and include some close-ups. If this is not possible, try to be present when the evidence is removed and document the procedure. Unfortunately, sometimes by the time you get the claim, the insured has replaced the failed component. But do what you can. Ask them to take photos of the failed component before they remove it and to keep it secured until you take possession. You're in a tough spot. You need to have the insured mitigate their loss while preserving the evidence. Before we attend, or if you're unsure that you need a forensic expert yet, we encourage you to document the scene and photograph the evidence in a particular way that will help you down the road with potentially pursuing subrogation. Generally, experts are trained to shoot photos in groups of 3s. First, take a large overall of the subject, then a closer field to narrow the focus, and finally, a close-up of the point of interest. Let me give you an example. Take a photo of the room where the incident took place, then a close-up of the area of the interest, and finally, a close-up of the component. Often we receive extremely close-up photos without any context, and I have no idea what I'm looking at. Or we receive a photo of a room with no indication of what they want me to look at. Shooting in 3s gives context and effectively documents the scene. In this photograph, we show a view of the property at the lost location. It's just for confirmation of address. Next, it's an overall of the area where the incident occurred. In this particular case, it's a kitchen sink. Next, we're closing in towards the area where the incident occurred. In this particular case, the water discharge occurred from the braided hose on the faucet. We take a close-up view of the component that failed. You can see the braided hose, it's damaged. And finally, we take a close-up view of the component that failed, including the area of interest. In this case, you can see the braided hose has a perforation in it. Other important information to document is the manufacturer's label, maintenance tags, or any inspection information present. This provides crucial information on the age of the appliance, the component, and its service history. Do not ignore warning labels, as they oftentimes offer useful information. And finally, take a close-up view of the component that failed after it's been removed from site. It is important that you know what was removed and who removed it, in case something is missing or we need any additional information about the installation. Sometimes I received evidence that is missing a key component. If we know who removed it from site, we'll be able to recover the missing component. It's extremely important that you protect yourself from accusations of spoliation of evidence. Warn your clients not to allow changes in the condition or the removal of the evidence. If possible, don't call the contractor that installed the component, because there might be involved parties if it turns out that faulty installation caused the failure. Take good photographs of the area and the failed component. If you can't get to the site right away, tell your insureds to take photos in threes, as I mentioned earlier. First, take a photo of the room, then a photo of the area of interest, and finally, a photo of the failed component. Prepare a chain of custody document to track the whereabouts of the evidence at all times. Include date and location of the incident, a description of the sample or part, the manufacturer's name, the model, and the serial number if they're available. Have all the attending parties review and sign the document, and attach a photograph if possible. Another important point to protect yourself from spoliation of evidence is transporting the evidence correctly. Whether an expert attends the scene or not, make sure your physical evidence is protected during handling, transport, and shipping. Properly packing and securing evidence from damage during transportation is crucial. The photo on the left shows a braided hose like the ones we're looking at today. It's been wrapped in bubble wrap and put in a box. As you can see, it's very nicely done and secured. On the right, we have a larger component, and it's put in a skid, and it's protected all around for transportation. So these are two very good examples. First thing we do when we get to the lab is an understructure test, meaning we do not crack anything open. We only do a visual inspection. The main steps during an understructure test include a visual inspection of the component and a microscopic examination. Then I typically report to my client on our findings and advise them of any interested parties so that they can be put on notice. Then we start to prepare for destructive testing by scheduling appointments with the interested parties. The objective of our non-destructive testing is to, first, find out what happened, and second, find out why it happened. So what happened could be determined by looking under the microscope and finding that there's evidence of creep in a coupling. And why it happened could be that creep took place due to a manufacturing defect or improper installation. So let's complete a typical examination on the braided hose that failed in the demonstration earlier. When looking at braided hoses, there's three main components that fail, and each one of those has its own failure mechanism. Let's look at the coupling. The most common failure in couplings is creep. Creep rupture mainly occurs due to a crack that propagates slowly into the material, and basically it leads to an unexpected failure of the component, like we've seen here. There was no indication of any damage or any degradation in the component, and then the sudden failure. Creep, especially in these couplings, creep is accentuated at areas of high stresses. And in this particular one, the threads of the component or the threads of the coupling are all the way to the base of the coupling, and we know by experience that the material itself is susceptible to creep. At this point, I want to take this to the microscope and take a better look at higher magnifications. So now we're here at the microscope, and we want to understand how this failure happened and why it happened. Basically, what I see here is very characteristic of creep, and now I'm going to document in more detail all of those features that I see. Look at this other issue here. The threads go all the way to the bottom of the coupling. That creates stress, and that is a manufacturing deficiency. The design of the coupling was not appropriate, and it likely caused a failure. And I'm going to report back to my client and say that the manufacturer should be put on notice. So here's a close-up of the braided hose. On the left, you can see the fractured parts, and on the right, you can see a close-up of the fractured surface morphology. The next section of the hose that fails is the braided material itself. In this case, we have a stainless steel braided material, and the most common failure in this is corrosion. Corrosion typically happens in stainless steels due to the presence of chemical agents, sometimes stored chemicals or cleaning products underneath the kitchen cabinet or the bathroom cabinet. The microscope is a great tool to understand how corrosion happens in these braided hoses, but first things first, let's document it, make sure we take some notes, document the manufacturing markings on it. So let's get right to it. After the microscope. So we're now here at the microscope, and we want to look at the corrosion issue in more detail. Basically, with the microscope, we can get some very good close-ups, and as you can see here, we can find out how those braided wires failed. So we can see the braids basically sheared perpendicular to the axis, and what that means in this type of material is, in the most cases, stress corrosion cracking. That type of corrosion typically occurs because of chemical attack on a material that is not adequate for the application, or simply substandard. So now that I've determined what type of corrosion we're dealing with, now I can understand what the next steps I have to do. In this particular case, I want to look at what the chemistry of the material is and what the microstructure is. In essence, if the chemistry of the material, in this case, is a stainless steel, if the chemistry is off, is not within a certain range, then the corrosion is going to take place and we're going to see this type of failures. But sometimes the chemistry is ballpark within range and the microstructure is off, and that's another issue that can cause this kind of failure. So let me show you here how these braids should look like. You can see they should look smooth without any signs of pitting or cracking, and that's what we want to see. We don't want to see any cracking, any corrosion there. Unfortunately, we see these type of failures very often, and you can see the braided hose. It's very hard to tell whether there was an issue on it beforehand. Here's a close-up photo of the braided hose with the corrosion issue. The arrows on the left photo point toward fractures of the braided metal. Also, you can see there's rust on the surface of the braids, and it all indicates that corrosion was an issue in this case. The photo on the right shows one single metal braid. It's a cross-section through the entire length of that braid, and you can see in the insert how deep and how much material was lost, and in the insert you can see how deep the corrosion has gone. The other common part of the hose that fails is the inner hose. Basically what happens with the inner hose, it can degrade and water starts seeping through the cracks and leaking out. In this case, the inner hose you cannot see because it's contained within the braided material. Typically we have to do destructive testing to understand what goes on on the inner hose, and assuming we can do that, then we would cut into the material or the hose and expose that inner hose. We would basically take it to the microscope and look at it. Today, for the sake of the examination, let's go ahead and cut a section of it, and I'm going to show you how it looks under the microscope. So now that I have exposed the inner hose, let's go to the microscope and see how it looks. So let me show you first how a perfectly healthy inner tube looks like. You can see here is the white inner tube. It has some yellowish discoloration. That's normal. The water tends to do that to the plastic tube. Basically, very smooth surface. There's no cracking, there's no damage whatsoever. Now let me show you how a damaged inner tube looks like. So this is a close-up of the inner hose showing material degradation. You can see in the photos here cracks showing that the component's been degraded, and basically it just leaks from those cracks. So even if you can't see these cracks from the outside of the hose, failures deriving from material degradation of the hose can cause devastating damages and very expensive claims. Now let's go back to the water filtration system that failed in the beginning of the webinar, and let's go through our investigative process. So I'm in the kitchenette of the Origin and Cost Ancaster office. But imagine this was a claim in a commercial building where there was a water filter failure. At this point, I would have taken a picture of the building, and now I come inside and document the area. Remember what I said before about taking the photos in sets of 3s. So we have a typical setup water filter underneath the kitchen sink. In this case, it's a single canister filter. It can be multiple canisters and more complicated. But the basic concept is the same. They're connected to the water supply. Water comes in, water goes out. And if they crack, if they rupture, water spills everywhere and floods into place. At this point, we need to document everything. Markings, installation, all the details we need to complete the investigation. Remember, the canister in this filter was cracked, so we want to document the water pressure, and for that I have a simple gauge here. It's a simple device I connect to the water supply, and I can tell exactly how much pressure there is. It can be a lot more complex than that, and it connects directly to my computer, and I get readings per second. But in this case, just a simple gauge. So at this point, I've documented the filter, I've documented the installation itself, and I have all the details I need to complete my investigation in the laboratory. So what's left for me to do is to take the filter out and further document it, take it with me to the lab. So now that we have the evidence out, let's make sure we document it, and then we prepare it for transportation. We want to make sure the evidence is properly labeled and tagged for identification purposes. This step is crucial for continuity of the evidence. So here's a canister, and it's showing a circumferential crack right on the head of the canister. Let's take some photographs and document. You have to make sure to take photographs of any markings on the canister, manufacturer markings or installer's markings. Okay, let's open it up and see how it looks from the inside. So we can see the crack is running right through the base of the threads here. It runs all across the circumference of the canister head. You can see some discoloration on the fracture surface here, but we need to use the microscope for additional details. On the microscope, you can see the morphology of the fracture and signs that the crack propagated slowly over time. This is one of the most common failures we see in water filtration systems. So what I want to do now is look at the fracture under the microscope and try to understand a bit more on how and why it failed. I'm going to take the microscope top off. It's a lot easier for me at this point to handle this larger object. And so basically what I'm looking for is for that morphology of the fracture to understand a bit more on where it initiated, how it propagated, and all of that morphology linked to the origin of the fracture. If I see this crack from the inside, then I immediately notice it started at the very first thread, at the very sharp corner where it turns to the bottom of the canister here. And at this point, everything is pointing towards an issue with the material, an issue with the design of the component. Unfortunately, visual inspection is not going to be enough at this point to fully understand the failure mechanism here. So what I would do at this point is bring down all my notes and prepare a short report for my client and just basically explain that we need to put the parties on notice, especially the manufacturer in this case. And once we get together and we can do a joint destructive examination, we'll actually cut this part open, we'll show them the fracture surface, and we'll examine in more detail to confirm what the failure mechanism was and what really caused the failure of this component. Here's a close-up of the failed canister. The arrows in the photo point to the cracks. As you can see, those cracks run through the threaded portion of the canister. This is exactly what a typical failure deriving from a manufacturing deficiency looked like. Another common failure in water filtration systems is freezing. Freezing can sometimes be difficult to identify to the untrained eye, but a good early indicator is multiple branching of the cracks. It often leads to much more devastating damages to the water filtration unit itself. Sometimes the bottom can come off or the unit can shatter. It is beneficial to rule out freezing as the cause of failure early on in the process, so it can be dealt with accordingly. If we can identify freezing as the cause of failure, oftentimes there's no need for additional testing. Whereas when there's a manufacturing defect or an installation problem, we have to continue with a full investigation. So once I've completed my visual inspection, microscope exam, and determined what happened and why it happened, I proceed to report to my client, and the interested parties are put on notice for further destructive testing. Destructive testing can be as simple as sectioning the component to expose the affected surface and finding that there was a big void or inclusion that caused the failure. Or they can be very complex, requiring sophisticated imaging and analytical techniques. This brings us to the final section of the webinar, Subrotalk. There are a couple of tricks I'd like to share with you when it comes to preparing for subrogation. I mentioned this concept in the beginning of the webinar, but I really want to stress it again. I'd like to introduce you to what Origin and Causes President Masin Habash calls the golden rule, and that is, time is subro money. When it comes to subrogation, time is of the essence. Get control of your scene and evidence as swiftly as possible. The subrogation process starts here. You cannot afford to think otherwise. The longer the evidence is not preserved, the risk of compromised evidence increases, and as a result, your negotiating power decreases when pursuing subrogation. We understand you have competing interests in any claim you're involved in. There must be a balance between mitigating the loss, that is getting the scope, repairs, schedule of loss, and ensuring the recovery of the cost of your claim. A masterfully handled claim is one that indemnifies the insured as well as the insurer. So the next claim that hits your desk, remember the golden rule: time is subro money. And here's another trick on how to maximize your subrogation potential. A common question I get from clients is, what if there are no clear markings on a component? How do you identify the interested parties? There are a couple of ways we can determine interested parties. We come across so many components on a weekly basis that we become familiar with the different manufacturing signatures. And oftentimes, we aren't starting from scratch. One great thing we encourage our clients to do is to pick up an exemplar from the loss location. An exemplar is an identical component that is not damaged. And remember, exemplars are gold. So now you can see why the exemplar is so important. Basically, the exemplar is helping me prove that this isn't an isolated incident, but a systemic problem. The strategy of picking up an exemplar proves to be effective time and time again. And I'll leave you with this one last piece of advice. If you have a file that you don't know whether you should hire an expert or not, when in doubt, give me a call. We see a large volume of components every year, so what you may think to be a one-off situation, I may have seen 12 of them in the last 2 months, which means there may be a defect in the product. No component is too old or quantum of claim too small to give me a call and have a chat for free. We can use the information we already have to determine if there's any subrogation potential. Give me a call anytime. I'd be happy to have a quick discussion with you to decide together whether it's in your best interest to invest in further investigation. With that being said, I'd like to thank you all for joining me today in the lab, and I look forward to answering your questions.
All right, thank you very much everyone for participating. We have a few questions that have rolled in. Please feel free to submit your questions through the tool up on your screen. So we'll jump right into it. The first question here is, do you mind going through the 3-photo concept? The shooting photos in threes.
Thank you, George, and thank you everyone for tuning in today. Basically, the concept goes back to trying to present what are you looking for, basically what the component that failed is. In this case, 3 photos will give you context as to where the location of the component was, and its particulars in regards to the installation. Say, for example, you're looking at a water heater tank. So the first picture could be the general room where the water heater is located. Then the second picture could be of a more detailed close-up of the water heater itself and its plumbing connections. And then the third picture would be of the particular component that failed, say a pipe, a fitting, something on those lines, yes.
Great. Next question. When you open the top of the water filtration system, was that something that would need to be done in the destructive examination process, or would that be something that is justifiably done in a non-destructive test? You know how you unscrewed the top and then you pulled out, I guess, a filter? So is that something that should be done in a destructive exam?
Thanks for the question. That's actually a very good question. It's not considered destructive. That is part of the visual examination. We're not destroying the part. It is very important, though, to document every step of the way. For instance, and George, by the way, I actually have an exemplar water filter here. So in case like that, it would be important to document the external condition of the filter. And because we're going to be removing the top, it would be important to document the position or how tight this was tightened in. In that case, we would mark it down, take photographs of that, and then after we open it, we can examine the inside. Pretty much in many of these filter cartridges, most of the markings are on the inside. So to identify the manufacturer, we have to go and look on the inside. And then once we finish with that, we can carefully put it back together, and we can line up the marks again, and it would be in the very same condition as we received it.
Great, thank you. Got another question here. Would there be a reasonable method to record the torque necessary to remove a failed component, or would the likelihood of contaminants on the threading make such testing unreliable? So it seems like this is with regards to, similar to what you just really mentioned, was like determining how much pressure was applied in order for you to like close something. So he's saying, like, is there a method to record the amount of tension that is present in the braids?
Let me see if I understand the question correctly. The question goes by how much torque is there in a threaded component, and is there a way to measure that torque before we actually disassemble it? As a matter of fact, yes. There are some digital torque meters or some analog torque meters that we can use to measure that torque on a component before it's disassembled. Some components are going to be very tight, but in the case of in some components, once they break, that locking mechanism is relaxed, and some of that torque is lost, so they're kind of loose. I hope that answers the question, but I'll be happy to take a different angle if you need.
Okay. Another question here. I've had several claims with solenoid valves that have degraded. Is that essentially the same degradation discussed about the inner hose of braided hoses?
Thanks. That's actually an excellent question. And it talks about degradation of polymers. The question asks on whether the degradation on a braided hose, like the one we saw before, is similar to that we would have seen in a solenoid valve. I have some solenoid valves here. Let me just pull them out. So, this is a typical solenoid valve in a dishwasher. As you can see, it's the body is made of a polymer, and the inside components are also polymer, different types. This one I have on my other hand is the same exact type of solenoid valve, except is broken, as you can see, and this caused quite a bit of damage for this claim. So going back to the degradation itself, basically the polymer degrades, and let me show you something on the microscope as how it looks and how we use the equipment we have to determine degradation. Okay. So this is how it looks under the microscope. It's a very general frame at this point. I'm going to zoom in to see what's going on. Basically, the water runs on the inside of this feature here, and it flows from the water supply into your dishwasher. Let's see how it looks inside. Okay, let's try to focus here. Okay, first of all, let's understand one thing. This is a 3D digital microscope. It's a very fancy equipment. In typical microscopes, what you would see is a very blurry image with a tiny area that's on focus. I'm not sure if you can pick that up, Nick, here. the 3D microscope has the ability to let you run stacked images and get you a full frame in full focus. And that's very useful for our investigations. You can see here, it's going to take a couple more seconds. It's going to render that image, and you can pretty much see the cracking on the inside of that wall. Nick, if you can focus on this area here, all of those are cracks on the solenoid valve, on the plastic component of the solenoid valve, and basically that's what caused that one to break apart. Sometimes they don't break, sometimes it just leak, and it's just barely before they finally break. Hope that answers the question.
Great, thank you, Eduardo. Another question that's just come in. Do you have a top 3 list of failures that you see that presents the best opportunity for subrogation? A top 3.
That's a good question. Very good question, actually. There's a large number of components that present very well for subrogation. In particular, I think that the braided hoses that we talked about today would be on that list. The water filters, as well as the solenoid valves. Why? Well, basically because they're well understood, their failure mechanisms are well understood. We can manipulate the items easily. They're small enough so they can fit in most microscopes. The case being this one here, as well as scanning electron microscopes, which are much more sophisticated. That's just a list of 3, but again, there's many other objects and parts out there that present well for subrogation.
And obviously, they're so widely used. There's such a high volume in the market, where it's not a rarity that these failures take place. They happen so frequently that these companies are obviously being approached by people every day with failures. So that probably helps the probability of a subrogation to actually be successful, because they know that there are several instances that these failures do take place. Another question here. How can you identify the manufacturer on a damaged flex hose?
Thanks, George. Identifying the manufacturer is a very important part of the investigation. Oftentimes these braided hose fail because of manufacturing deficiency, like we talked before in the webinar. Most of these hoses have, let me just pick one up very quickly. This one is for a water heater. As you can see, this is much larger than the one for the toilet or for the faucet. Lots of them have a tag, but they're all required to have a markings that cannot be removed. So in this case, they have engraved markings naming the model or the manufacturer name. That you can find them on the fittings. You can find them on the crimps. Sometimes they're very small, very blurry to see, and sometimes we have to use a microscope to find them. But they are required to have it, and normally we can find them without much trouble. Sometimes, though, the markings don't point anywhere. Sometimes there are some markings and they don't point anywhere. In that case, it's very important to understand the installation as a whole. There's a particular type of toilet connectors, toilet braided hoses, that don't have any markings that directly identify a manufacturer, but they only come with a particular brand of toilets. So by knowing that that braided hose was connected to that toilet, we can identify the manufacturer in a way. Hope that answers the question, George.
Great, yeah, thank you. We have a ton of questions. Thank you, everyone, for submitting these questions. If we don't get to them by the end of this, then we promise that we will follow up with you. We also are recording a podcast as well, so you can hear your answers there, or our answers there. Another question here is, are there any precautions or maintenance measures that an insured can do to prevent braided hose failure? Should they be replaced every year? How long do these hoses usually last without failure? Thank you.
Thanks, George. That's a very good question, actually. As you can see from the webinar, there's three major components, or three major failure mechanisms for the braided hoses. The coupling fails, the braided wires corrode and fail, or the inner hose degrades and fails. Basically, not storing chemicals underneath the kitchen cabinets or the bathroom cabinets, that certainly helps. Let me show you quickly the one, the hose that I presented before, right? So it has corrosion, most likely. So in this particular case, corrosion happened because chemicals were stored underneath the cabinet. It can also be a matter of the material not being properly made. And in terms of the life expectancy of these parts, basically most plumbing components should last at least 50 years. So the fact that they're failing at 2-3 years, well, that's early, but the fact that they fail at 7, 10, 12 years, and I get these questions a lot, so this component failed after 12 years. Does that mean the component was old or wear out? No, not really. They shouldn't fail at that age, and they shouldn't fail in a way that is unexpected. If you see a lot of rust on them, if you can see them degraded, of course it's a maintenance issue. But most of these components we see don't show any signs of degradation or damage before they fail. So it's a tough one.
So if you have a component that is 20 years old and it fails, not due to like external circumstances, you would say that there's still an opportunity for pursuing subrogation?
Absolutely, yes.
Because they should last for around 50 years or about over 50 years?
Right. So most plumbing components should last at least 50 years. And when they're designed and tested in the research or design process, they can last up to 100 years in their accelerated testing. So that being said, a component that fails after 20 years without any external components, any external factors affecting it, it is clearly a good component to be used in subrogation. Yes.
We've had several questions coming in exactly about that. How about if it exceeds a warranty or an the average lifespan? They keep referring to 10 years, 20 years. So several people are having that same question, and I hope that answers your question.
Let me just add one more thing on that, and that part of the question where they talk about lifespan or warranty. Basically, warranty doesn't have anything to do with liability in this case. But let's not go too much into that detail. Basically, warranty is typically 1 or 2 years, and life expectancy, let's say for a refrigerator, is about, say, 15 years. That's what it's understood out there. What happens after 15 years? After 15 years, it doesn't mean the refrigerator is going to break apart and fill your house, flood your house, or fill your house with Freon or whatever refrigerant they use. What it means is that's the average for the major components to fail. Say the motor, or in this case the compressor, gaskets, seals, things like that. So the refrigerator is going to stop functioning properly or stop functioning at all, but it doesn't mean it's going to cause damages to your house or your property.
So before we run out of time, I just wanted to quickly run through who Origin and Cause is, just in case if there's people out there that haven't worked with us before and just want to understand a little bit more about our services. So here's some quick facts about Origin and Cause. We've been in business for 25 years. We're the largest forensic engineering and fire investigation firm in Canada. We have 11 locations and over 35 experts. Our locations are in Ancaster, Mississauga, Kingston, Ottawa, Sudbury, London, Windsor, Halifax, Winnipeg, Calgary, and Edmonton. Our geographical spread has proven to be a great strategic advantage for us. Our clients love the fact that we're able to get on site quickly, to control spoliation, and to complete our investigations very quickly to provide them reports instead of waiting on someone having to travel several hours. Usually we're pretty local and we're able to get someone out very quickly. We've worked really hard to become a national forensic solution for our clients, and we're preferred vendors on the list of all the large insurers in the Canadian market. And for those insurers and firms that do not have a preferred vendor list, we're amongst the leading firms that are actually retained for forensic investigations. Let's go through our services very quickly. We do fire and explosion investigations. We have a K9 unit. In these photos here, you could see Smoke, our fire detection dog. He's going through a scene there, just trying to see if there was any accelerants used in that particular fire. We have a structural engineering unit, an electrical engineering unit, which Mazen Habash is actually a part of. We do alarm system investigations and analysis, so you could see Mazen there in the lab. We have a mechanical engineering unit, a materials and metallurgical engineering team, a chemical engineering unit, and we also do forensic litigation services. We're industry leaders when it comes to forensic litigation experience. Origin and Cause has been involved in over 1,500 legal cases. We're qualified as expert witnesses in all levels and types of Canadian courts and have testified as expert witnesses in over 170 litigation proceedings in Canada, the United States, and internationally. So as you can see in these four bubbles, 6% of the litigation proceedings that we've been involved in have been relating to electrical engineering files, 12% relating to mechanical engineering, 4% related to materials and metallurgical engineering, and 78% relating to fire and explosion investigations. Also, I want to encourage you guys to check out our website. It's origin-and-cause.com. We have a lot of great resources, and even on the side panel, this is something that our clients love. There's those two little red buttons. The top one is send a new assignment, which makes it very quick and easy for you to hit that button and very quickly tell us a particular loss or an occurrence that you have that you're dealing with, and someone will contact you within 15 minutes. Right when you send in a submission, that is emailed directly to me and to Mazen, and we will be contacting you, or someone else will be contacting you very shortly to make sure that your file is addressed and investigated immediately. We also have another button right under it, which is ask a question, and that goes to me and Mazen as well. If ever you have any questions, you don't necessarily have a particular file, but you have a question about something that just came in, a new claim, and you want to speak to someone, you click that button, you ask the question, and someone will call you right away. As I'd mentioned, on the website, we have a lot of great resources. These are a bunch of articles that we've prepared, and we push them out every month in our newsletter. Some of the topics have been 3 questions adjusters should be asking on the day of an incident, what's the most common appliance fire, experts say dryers, 5 common culprits in residential electrical fires everyone needs to be aware of. So there's all these great topics. They're designed so that it could be read within 5 minutes. I'm imagining that you probably get into the office, you're checking your emails, you get your coffee or tea, and then you have enough time to read this article and get back to your work, of course. And the objective is for you to learn something from that article that you can directly implement after reading it. So they're very, very practical. So that concludes our webinar. We'll be sending each of you a completion certificate in a follow-up email. If you're in a group, make sure that you email me your name and your contact information so I can get you that completion certificate. You can email me at webinar@origin-and-cause.com. And as soon as the webinar ends, there will be that window that will pop up. It'll ask you 6 feedback questions. As I'd mentioned several times, we'd love to hear your feedback so that we can improve future webinars. Thank you again, everyone. We appreciate you all joining us today. Have a great day.